Part 1. So, in order to talk about this next one, so this learning target is I can describe and graph what we're going to call compound inequalities. Okay? And a compound inequality is an inequality that contains the words and or. And we're going to clarify that. So before we start to talk about what compound inequality means in math, let's talk about what it means in life and every day. And I think back, I used to teach English, but a compound word. Like, what is a compound word? It's a word that is made up of 2 words, right? So like sidewalk, they're each separate words in and of themselves. Chalkboard, they're each separate words, okay? So then you were asked to think about what a compound sentence is. And then when you were in kindergarten or first grade, I'm seeing it now with my little guy, all of your first paragraphs were, I like football. I like gymnastics. I like every single sentence you ever wrote started with the same thing. And teachers were like, that's great. Now let's spice it up a little bit. Let's use a conjunction. What is a conjunction? It's a connector word, right? Conjunction, junction, what's your function? Do you ever hear that? Yeah? Okay. So a conjunction connects. So a teacher may have said, let's take your sentences that are to I like football, I like gymnastics, and let's just make one sentence, remember? I like football and gymnastics. So we use the word and to connect sentences. So we're going to use the word and today to connect inequalities. Okay? So I want you to take a look at this inequality. Let's take a look at x is greater than 5 and x is less than 8. So as you're looking at that, I'm going to find my notes. As you're looking at that, you say to yourself, if this was not even a math class, if somebody just walked up to you and said, hey, give me a number that's greater than 5 and less than 8, how many numbers would there be that satisfy both of those? Because, let's back up for a second. Let's talk about the difference between and or. And means both have to be true. So it's Friday night, you go home, and you want to go to the football game. Your parents are going to say to you, you have to do the dishes and the laundry before you can go. You have to do both, right? Yeah. If they were to say to you, you either have to do the dishes or the laundry, do you have to do both? No, you get to pick which one, okay? Always choose laundry instead of dishes. Yes, okay? So, and both needs to be true. And an or, only one would need to be true, right? That's kind of the definition of and or. So, if I were to say to, give me a list of all the numbers that would fit in this solution set, if this one wasn't there, it would be all numbers greater than 5, 6, 7, 8, ... If this wasn't there, it would be 7, 6, 5, ... But because we're doing compound inequalities, they both have to be true. How many numbers are we talking about in our solution set? Sam? Yeah. You got it. Just 2. And what are they? And do I do ... I started to because that's a habit, but so I got to try to cover it up. So 6 and 7 are the only 2 numbers that are in this solution set. Okay? So the next thing was graph, right? So we did our number line. So let's see what this would look like on a number line. Okay? And to start it off, you're going to put the numbers where they are in relation to each other on a number line. So if you switch this around and put the 8 here and the 5 there, you're totally off because 5 is to the left of 8 on a number line. We need to know that. Then you do your circles. And then you decide if you're going to shade those circles in or not. Can it be 5? And can it be 8? No, we're going to go back and change that, and we'll see how that affects it. And then here's how you're going to see it two ways. If this, and I always kind of tell kids, just ignore one of them for right now and just graph one of them. This arrow represents all numbers greater than 5. This arrow represents all numbers less than 8. Right? But that's kind of a sloppy graph because all I really want to know is where is there an overlap on the graph? Do you know what I mean by that? So, is there an overlap at 5? Be careful here. Because it looks like there's 2 lines there, but 5 is not colored in. So, the overlap takes place between 5 and 8, which is where you already told me. So, this is with them both done separately. That's not how you're going to see it, though. You're going to see it like this. Okay, do you see the difference? This one includes both of them graphed separately, so it kind of like includes all the numbers that are greater than 5 but are greater than 8, which I don't want. And it also includes all the numbers that are less than 8, but they're also less than 5, which I don't want. I want them greater than 5. So do you see what I mean by overlap? So the overlap is where you follow a number up and it hits both of the highlighted lines. And there is no overlap at 4, right? There's no overlap at 9 because 9 and 4 are not part of that solution set. Only 6 and 7 are. So how would that change things if I were to put a little line under that 8? So I want the numbers that are greater than 5 and less than or equal to 8. That means that this gets colored in. And now, is there overlap at 8? It's colored in here and covered here. So now it can be part of my set. Do you see that, the difference? Okay. So that is our typical and. Okay. Now, we need to talk about when you take that sentence, I like football, I like gymnastics, I like football and gymnastics. So we're going to take this and rewrite it into one inequality. And this is where it really kind of gets tricky. So take a peek at this. I want you to write the X, and you're only writing an X once, just like you're only writing I like once. Then on either side of the X, you're going to write the two numbers in relation to where they are to each other. So don't put the 8 here and the 5 there, right? Put the 5 here and the 8 there. And now I need to fill in with some signs. Well, I know that X is less than 8. We'll just go with the original. You don't have to color it in. Now, I got to kind of figure out what to put here. It's got to be another inequality sign. But I have to figure out, remember how it's on the right? We don't like it when it's on the right because it's kind of confusing. But it was given up here like this. Here is your advice. Find the nose. The nose. It's pointing at the 5, right? So when you make this inequality, it still better be pointing at the 5. So, you're going to see something like this today for the first time, and you may not know how to read it. And that's what I'm going to teach you right now. So, this is another way to write that X is greater than 5 and X is less than 8. It was just combined. I only wrote the X once, and then I wrote the 5 and the 8 there. So, how do you actually read this? Listen to how you would say this. 5 is less than X, which is less than 8. 5 is less than X, which is less than 8. So you're only saying the X once. So, when you get to a compound inequality like this, we're kind of already confused a little bit when it's backwards like that. So my advice to you is if you're not comfortable reading it like this, can you separate them and make them two? Absolutely. If that's going to help you kind of keep it straight in your head, you're going to look at this. And the cool thing is, like, one of them is already, I'm just looking at, oh, x is less than 8. Great. It's the other one. If 5 is less than x, that must mean that x is greater than 5. So you just got to be real careful with that. So x is less than 8. So you can separate it like that. Okay? And that's really a compound inequality with and right now. So let's take a look at this one. Hold on. I had it. I got to think of what. X, 1, 2. Okay. So if we weren't even using math, if we were just using common sense right now, you have to be able to read this. This says 1 is greater than x, which is greater than 2. And what are you thinking right now? It doesn't really make sense, does it? Because I'm asking you to read and give me a number that is greater than 2 and a number that is less than 1, and there is no such number that would fit that, would there be? Not a number you can think of that would satisfy both of those. So what we do is we always make our list, right? So I'm going to teach you a new symbol here. And if I were to put 0 here, that would mean that you are telling me, because remember, every time you see these little brackets, you're saying, I'm about to list a set of numbers. You would tell me that 0 was in that set of numbers, and it's not. So it kind of looks like a 0, but it has a slash through it. It doesn't mean 0. It means empty set. Which is so silly. Sometimes people kind of think that empty set is silly to do, because I'm asking you, what is the set of numbers that satisfies that inequality? And you say that set is empty. Well, it makes sense, right? It means there's no numbers that satisfy that. So there are no numbers in the set. It's empty. It doesn't contain any numbers because there are no numbers like that that exist, right? Okay? So, and if I were to graph this, what would that look like? These are the numbers greater than 2. These are the numbers less than 1. And where is their overlap? Nowhere. There's no overlap, which means your answer is an empty set. Got it? Okay. Now, if I were to say, this one here, if I were to say, let's do 5 and 8 again. X in the middle. X greater than 8. I'll give you a minute to kind of look at that and try to think about what it means. I want 5 less than x, which is greater than 8. So, your choice here is, I'm going to maybe ask you to list some things, but it might be easier to kind of look at it as a graph first, right? So here's 5, here's 8, and you know what it might be easy to do first? Separate them, take them apart. You want to look at all numbers greater than 8, and then all numbers what? Greater than 5. It's an and, so here is all numbers greater than 8, and here is all numbers greater than 5. So where are the numbers greater than both? The first whole number wouldn't start until where? 9. You got it. Okay? So x would equal, and how would I start my set? 9, 10, 11, ... Okay? Because where does the overlap start? at 9. Okay? If this were to be this line here, that would mean that the overlap actually started at 8, and 8 would be a part of your solution set then. Do you understand? Okay. So this is your and. So here's what can happen with an and. We talked about 3 things. Either they kind of crisscross each other, and that's the overlap in the middle. Either they're not going to crisscross each other, they're going to go in totally opposite directions, which means empty set. Or they're both going to go in the same direction. And at that point, the overlap doesn't start until the bigger number, right? Okay. Comfortable with ands? All right. So let's talk about ors. Ors is a whole different ballgame. So those were the and. Let's do the or statements. Okay. First of all, or statements, you will be relieved to know, cannot be combined. That's an N. They cannot be written in that combined way. So that's the first important thing, I guess, is for you to know is that if you do see it combined like that, you know it's an and. So you know this is an and. Because ors cannot be written like that. Pretty important. Okay? So let's do x greater than 12 or x less than 16. So now we got to change our frame of mind and think for a minute that, okay, or means only one of them needs to be true. So am I looking for overlap now? No, overlap is and. So I really feel like your list will come if you are able to graph them correctly. Okay, let's just put a line under that one. I'm going to get practice with that. So draw your circle, color in the ones that need to be colored in. And now let's draw our lines. I want all numbers greater than 12. Well, you know what? It's all numbers forever in that direction. And then all numbers less than or equal to 16, which is all numbers in that direction. So if the graph that you're looking at is an or, I would think what? I'm only looking for no overlap because that's an and. I'm just looking for where on this graph is there at least one line above it. Everywhere, right? So let's pick 11. Is 11 greater than 12? Nope, but that's okay because it doesn't have to be. As long as it's less than or equal to 16, it's good, right? Is 17 less than 16? No, but that's okay. It doesn't have to be. It's greater than 12. Do you see what I mean? It has to just fit one of them. And doesn't every single number fit at least one of them? Some fit both, but that's okay still, right? So it can satisfy both inequalities, but it doesn't have to. So what would your solution set be for this? X can be, bless you, all real numbers, because every single number works like that. Okay? So let's do this one then. So x is greater than 9 or x is less than 2. And let's throw that one there. So, I want you to either give me a number that is less than 2 or greater than or equal to 9. So your best bet might be to just do your graph. Always put them where they are in relation to each other. on a number line. So let's graph x is less than 2. All numbers this way. Let's graph x is greater than or equal to 9. Now, if I were to ask you to list all the numbers, there's a whole lot to list, right? And that sounds kind of silly because wouldn't this just be your answer? Couldn't x equal 9, 10, 11, ... But it could also equal 1, 0, -1, ... So sometimes when there's a whole bunch, do you think it might be easier to say the numbers that x cannot be? This is where your brain really can try to start to trick you. So looking at your graph, where is there at least not one line covered? Is there one line covered at 2? No. 3, 4, 5, 6, 7, and 8. Is it covered at 9? Yes. So x cannot be 2, 3, 4, 5, 6, 7, or 8. And if it's any number but those numbers, you're good. Because it will fit and match one of them. Do you understand? Okay? So sometimes it's a little easier to just say all the numbers that x cannot be. And if it's not one of those, then you're good. All right? Good so far on or? Yes, Isaiah.
What about the
9? Okay, this is where I said it. Your brain starts to play tricks on you. It can be 9. So that's why 9 is included in this one, because if I say 9, then it satisfies this one. That's why 9's not in this one, because this list is the numbers that it can't be. You got that? It really starts, gets you thinking. Okay, and we have one more to do. Are you ready? X is greater than -4, or x is greater than -7. Okay, so let's see what our graph would look like. First of all, if 0's over here, you need to know that -4 is here and -7 is here. I'm telling you, this is one of the biggest mistakes that will mess people's answers up. Because they'll actually plot those wrong. So, circle them. Don't color either one of them in. Here are all the numbers greater than -4. Here are all the numbers greater than -7. Remember, it's an or, so I'm not looking for overlap. I'm just looking where is there at least one of these that fit. Is -8 greater than either of these? No. Is -7? No, because it's not colored in. So where is the first integer, not whole number, but integer, that would make this true? -6. So x could equal -6 and then -5 and then -4 and every number to the right. Because in an or, there only needs to be one line showing. So there's one line for this, there's one line for that. If this were an and, if I changed that word from or to and, how would that change my solution? This is my solution if it was an or. What would my solution be if it was an and? Emma. Think, where's their overlap? Almost, because she's got it. Yep, that's good. She walked through it. If 4 was covered in, it would be yes. So good. -3, -2, -1, ... So, or equals where is there at least one line covered, and means where is the overlap. Do you understand and or? Okay, because Monday, this is what you're going to be given. You're going to be given compound, look at that. How cool is that? So you have a 3-sided inequality instead of 2-sided. Here's what's cool. I want you to start thinking. If you just subtracted 6 from the middle, wouldn't it cancel it? Wouldn't it cancel it here and here? So Monday's gonna be pretty fun solving these inequalities like that. Okay.